reaction will be faster. Now we are going to study E2 reaction or E2 mechanism. Here E stands for the elimination, 2 stands for the bimolecular reaction. Now the mechanism is shown here. See here first, which is a substrate, which is a tertiary substrate. To this carbon, methyl group is there, another methyl group is there, another CBr bond is there, and to this carbon CH3 group is attached. Means to this carbon 3 CH3s are there. This 1, 2 and this CH3 group. 3 carbons are active. Methyl groups are attached to the carbon, therefore it is a tertiary carbon. See, CH3 thrice Br. This is your starting material, means tertiary alkyl halide is the starting material for E2 mechanism also. Now, in E2 mechanism, the base will extract the beta hydrogen. This will shift to form the pi bond between carbon-carbon and simultaneously CBr bond will leave. Therefore, this is only one step process. In only one step, all these things are happening. Means there is no transition state. Basically, as carbocation formation is not there. E2 requires the strong base. If the base is strong, rate of E2 mechanism will be faster, as similar to the SN2 mechanism. Then in E2 mechanism, there is no transition state, no carbocation intermediate. Then it is actually operating in tertiary substrate. Rate of reaction will be more in tertiary, then secondary, and then primary. Why this is so? Because in SN2 mechanism there is a problem if tertiary substrate is there. But in E2 elimination reaction, if tertiary substrate you are using, whatever alkene formed, that is a more substituted alkene, and therefore due to the plus I effect of methyl group, this is become stable, and due to that more substituted alkene is obtained from the more substituted starting material, and therefore the tertiary substrate react faster in case of the E2 mechanism. While suppose this substrate we are considering for the SN2 mechanism, then in SN2 mechanism, this is approach of the nucleophile comes from the backside, or nucleophile approaches to the carbon from the backside. If attack of nucleophile takes place backside, there are bulky methyl group like this. 3 bulky methyl groups are there. There is a strong steric hindrance between these bulky groups, 3 methyl groups. And due to strong steric hindrance, energy required will be very high, energetically not favorable. Therefore, in tertiary substrate, SN2 is not possible. While E2 is possible because more substituted alkene will be formed, which is a stable. Now, in this E2 mechanism, in continuation of previous, the another important point is it is a concerted reaction. E2 is a concerted reaction, means the bond breaking, bond formation takes place simultaneously. Now, here the beta hydrogen is extracted by the base, then the double bond will get formed between these 2 carbon, and simultaneously the carbon and halide bond C-X bond will leave. All these things are happening in only one step. Therefore, like SN2 mechanism, E2 is also one step process. But difference between SN2 and E2 is that E2 doesn't having any transition state, doesn't show transition state. It directly, after breaking of this, directly gives the alkene as a product. While in SN2 mechanism, it proceeds through, it is also one step process, but it proceeds through transition state, which is a pentavalent transition state, as I discussed previous, which is required high energy and therefore it will be immediately product. But such type of pentavalent transition state is not there in case of E2. There is no transition state at all. There is no carbocation formation at all. Directly the nucleophile means base act as a nucleophile, therefore it acts on beta hydrogen, this will fill, double bond will form between 2 carbon, and simultaneously CBr will leave. Order of reactivity in case of E2 mechanism is tertiary substrate react faster than secondary and then primary. As previously I told you, tertiary more substituted alkene will form, that will be more stable. Now we can compare the E1 and E2 mechanism. As you know, E1 mechanism is 2-step process, while E2 mechanism is only 1-step process. Now, here in even mechanism, carbocation is an intermediate, while in E2 mechanism, carbocation doesn't form or any transition state doesn't form. Now, kinetic study shows that rate of even mechanism is directly proportional to only concentration of the substrate. While therefore hence it is unimolecular reaction, first order reaction. While E2 mechanism, rate of reactions shows that rate of reaction depends on the alkyl halide, that means starting material, reactant or substrate, as well as concentration of base is also involved because it is only one step process. Therefore rate of reaction depends on two species, hence it is called as a bimolecular reaction. Now, in this case, the rearrangement takes place in even mechanism because there is a carbocation formation. If primary carbocation is there, and if there are chances of formation of the more stable secondary or tertiary carbocation by migration of some group, then the rearranged product will be obtained. While in E2 mechanism, there is no carbocation formation and therefore there is no rearrangement. Then base or nucleophile. That base strength is not important in case of even mechanism. Generally, the weak base undergoes the even mechanism. While here strong base is required because in one step attack of the base takes place in RBS. Therefore, if base is strong, then the rate of reaction will be also fast in case of E2 mechanism. Now, as there is a solvent effect also, if a solvent is ionizing means polar in nature, then it is good for the even mechanism, rate of reaction will be faster. Why? Because in even carbocation is there as an intermediate. Carbocation formation is the first step. And if that carbocation gets solvated by the polar solvent, then that carbocation stability will be more, energy required will be less, and reaction takes place fastly. The polar or ionizing solvent increases the rate of even mechanism. While in this case, there is no carbocation, therefore solvent polarity does not matter. That is not so important in this case. Now, as already told, in both the cases, this order of reactivity is same. In even mechanism also tertiary react faster than secondary than primary. In this tertiary react faster because carbocation is the first step, that carbocation gets stabilized due to the inductive effect of the methyl group, and therefore rate of reaction will be faster in tertiary. While in E2 mechanism, tertiary react faster secondary and then primary. Why? Because the alkene formed, if you are taking the tertiary alkyl halide, the alkene formed is a more substituted alkene, and according to subjects, that will be the major product. Now, the last slide, which explains the substitution versus elimination. The strength of the nucleophile determines the order of reaction. How? If strong nucleophile is there or a strong base is there, that promotes the E2 mechanism, that is bimolecular mechanism. Strong nucleophile, strong bases increases the rate of E2 mechanism. If primary halide is there, then generally it undergoes SN2 mechanism because if primary halide is there, there are only hydrogens. Approach of the nucleophile from backside become easy, no steric hindrance, energy required will be less, and therefore rate of reaction will be faster. Therefore, generally primary halide undergoes the SN2 mechanism. Now, the tertiary halide, in that case, which mechanisms will be operated in tertiary halide? I told you E1 may operate, E2 may operate, or SN1 may be operated. Because in SN1 and E1, carbocation formation is there. If tertiary halide is starting material, carbocation gets stabilized. But and therefore rate of reaction will be faster. While in case of SN2, the tertiary halide is there, then backside attack of the nucleophile is hindered, sterically hindered, not possible, and energy required will be high due to steric hindrance, and therefore SN2 reaction doesn't take place in tertiary halide as a substrate molecule. Now the high temperature always favors the elimination reaction, then bulky bases and highly crowded leaving group also favors the elimination reaction. Thus, we covered many things in elimination, even mechanism, E2 mechanism, then the steps involved in that, that is E2 is one-step process, while even is two-step process. The carbocation formation, stability of carbocation, according to Selznick's rule, stability of the alkene, all these points we covered, and also how the pi bond formation takes place, how the attack of the beta hydrogen base abstract the beta hydrogen, all these points we covered. Also we compare the E1 and E2 mechanism, and also which substrate, if the substrate is tertiary, which mechanism will be operated, if primary substrate, which mechanism will be operated, that also we studied. And also how the temperature and leaving group crowded, strong or bulky bases are there, then it always favors the elimination than the substitution. Therefore, with these points, I conclude I covered some part of the elimination reaction chapter. Thank you. Thank you very much.